Hello everyone, now we are going to discuss about geometrical representation of Lagrange's mean value theorem. By the definition of Lagrange's mean value theorem, we know that if f of x is a function defined on a comma b such that f of x is continuous on closed interval a comma b and differentiable in open interval a comma b, then there exists at least one value for c in x in a comma b such that f dash of c is equals to f of b minus f of a by b minus a. In geometrical interpretation, let us assume two values a and b. Let y is equals to f of x represents a curve a comma with a comma f of a and b comma f of b are the endpoints between a and b, and c be any point between these points a and b such that c is equals to c comma f of c. The above graph correctly represents the geometrical interpretation of Lagrange's mean value theorem. We know that the derivative of a function at a point is the slope of the line tangent to the curve and the point. Here, f of b minus f of a by b minus a is slope of the chord AB, which we have seen in the above. By this we can say that geometrically Lagrange's mean value theorem says that the curve y is equals to f of x is continuous in the closed interval a comma b and at every point x equal to c, where a less than c less than b, at the point c is equals to c comma f of c on the curve y is equals to f of x, there exists a unique tangent to the curve. Then Lagrange's mean value theorem says that there is at least one point on the curve where the tangent of the curve is parallel to the chord joining endpoints a and b and the curve, since the slope is at c. That implies f dash of c is equals to slope of the chord, that is ab is equals to f of b minus f of a by b minus a. There are few special conditions in Lagrange's mean value theorem. Let us discuss about them. Condition number 1. In a particular case where the values of the function f of x at the end points of the segment a and b are equal, that is f of a is equals to f of b, then the mean value theorem implies that f of c is equals to f of b minus f of a by b minus a is equals to 0. Condition number 2. If the derivative f dash of x is 0 at all points on the interval a comma b, then the function f of x is constant on this interval. Indeed, for any 2 points x1 and x2 in the interval, there exists a point c belongs to a comma b. Let us see the problem of this. We know that f of x2 minus f of x1 by x2 minus x1 is equal to f dash of c. On further calculating, we get f of x1 minus f of x2 is equals to f dash of c into x2 minus x1, but it is given that the derivative is 0. Hence we get f of x1 is equals to x of x2. These are the special cases of the Lagrange's mean value theorem. Thank you.